All right, we are going to start a new unit in science, and we're moving on to a unit on energy. Say it with me, energy.
Energy.
We are going to work on our target today, which is, I will know how energy is used. Say it.
I will know how energy is used.
Before we go on, I need you to tell me some things. The word energy, tell me if you've heard the word energy before. Raise your hand if you've heard the word energy before. I got to see that you're really raising your hands. Thank you. 6, 7, 8, 9, 10, 11. Okay, raise your hand if you've not heard that word before. Fabulous. All right, will you put your heads together when I say go and tell me your prediction of what you think the word energy means. Go, heads together. We're going to try that one more time. I like your energy, but I don't like how loud it is. So when I say heads together, show me what that looks like. Heads together, make a prediction of energy. Go. Don't forget to be heads together. All right, time's up. Thank you. Nice job. I appreciate you listening and working heads together. Give me your prediction. What you think heads together mean? I mean heads together. Energy. Can you tell? My head is. Ryder, what do you got?
I think it's what wires are on.
What wires are on?
No, what wires run on.
What wires? You mean like the wires in the sky that we see like outside?
No, like the wires that you use for your computer.
Oh, computer wires. Okay, good to know. Eric, what did someone at your table say about energy? What's your prediction?
It goes something to.
Say it one more time. It goes something that's electrical?
No, it goes through like metal.
Okay, so I heard it goes through something electric or metal is what I heard. Nod your head if you think that sounds pretty close. Slava. When we eat food, we get energy. When we eat food. Fabulous. Who do I have left? This table? Are you my last one?
Yeah.
Gavin, what did you guys say?
Energy means like when so it means like when you're tired and then when you drink something then you have a little more energy.
So what's your prediction of the meaning energy? The meaning of the word energy?
That when you have too much energy you might go fast and crazy.
When you have too much energy, you might go fast and crazy. Okay? That was a long one. All right, we're going to stop with this right here, and we're going to look at our books and talk about some things about energy. So on the top of page 16, it says, how do we use energy? Look at that picture at the top, envisioning what is going on in that picture. Tell me what things in that picture use energy. What things in that picture use energy? Ella. Say it one more time. People are walking. Nice. Sophia.
Cars.
Cars use energy. Nice.
Yeah,
Elena.
Lights.
Lights use energy. Awesome job. What else can you tell me uses energy? Did I call on you yet, Slava?
No.
Okay, go ahead.
Car lights.
Car lights. Nice. So you guys named all the things I was looking for. Let's look at my planet diary and the do you know. Nolan, can you read for me in that box?
We can use the wind to make that electricity. What happens if the machine is a wind turbine? A wind turbine is like a giant pinwheel. The wind turns the turbine blades. The turning pins move parts inside the turbine. Heat that makes electricity.
Nice. Okay, here's your big question. Make sure your pencil's ready. Could these turbines make electricity if the wind is not blowing?
No.
Put your heads together. Talk about it. Go. Please not be so loud. Show me what you can do. Heads together, Kaden.
The wind
Show me.
wheel has to because if the wind wants to blow, then the wind has
We're gonna write in just a second. Okay, signs up. Thanks, Amari, for showing me with your eyes and your ears that you're listening. To answer this question, oh wait, Logan, till your bottom's in your chair. Thanks. Miles, we're going to answer this question. The question is, could the turbines, those fancy windmills, make electricity if the wind is not blowing? And then we need to say why. So yes or no? What's your answer?
No.
Ryder. No. Who can give me a why? Amari. You are so right. The wind is what creates the movement. So you're going to write no, comma, because the blades will not turn. I'll get mine out too. No, comma, on that pencil line. No, comma. So on the pencil line, you're going to write, maybe I'll try this again. No, comma, oh, there you go. Because the blades will not turn. I kind of went off the edge, but that is okay. So that is a reason why, let me zoom in for you. That is a reason why it would not make electricity if the wind is not blowing. Because the wind would not be circulating those turbines.
Is it T-U-N?
Turn, T-U-R-N, yep. Yep, do your best. Good, we're going to go to the next page in just a second.
Page 17.
Nope, not till we're all done. All right, as soon as you're done, we're going to go on to the next page. You have about 10 seconds to finish that. All right, let's take a peek at this side of the page. And we're going to touch the word energy. Say it.
Energy.
Good. Hey, Slava, will you read those words there for me under energy?
If you turn on the wind, electricity makes makes the lamp glow. The lamp will not glow without electricity. Electricity is a kind of energy. Energy can cause changes or do work.
Exactly. So we are going to look at that picture. When we turn the light switch on, for instance, this, what happens?
Energy.
Yeah, the electricity, the light switch goes on, a form of energy is on. So cause and effect in this paper says, write what happens if you turn off electricity to the lamp. So all of a sudden, the lamp has no electricity. What happens? What's the effect here? What's the effect? Jared?
Go off.
The lamp will not do what?
Glow.
Glow, exactly. So we're going to write that on the line. The lamp will not glow. It's important for you to realize that electricity is connected to that lamp and turning it off and on, and that is a form of energy. It's going to follow me if I go backwards.
It looks like it lost hold.
Okay, you have about 15 seconds and we're going to move on, friends. Oh, it did lose me. Come back. Do I need to go back? Okay. Fabulous. Oh, you don't need to touch this yet. If you're done, would you show me quiet fingers so we can move forward? Okay. So we have discussed a couple types of energy. We've discussed the electricity, and now we're going to dig deep into a different type of energy. Are you ready? So we are going to turn a couple pages, so you have to make sure you can follow me for this next step. You're going to turn to page number 20. So it's 2 pages.
Here. Oh, that's 19. Oh.
2 pages. And let's see if my computer's being friendly, because I have a really cute video to show you about this.
That would be 19.
Okay. So we're going to try this hands-on. Another form of energy is called heat. Who knows what heat is? What is heat, Isabel? Fire is a great form of heat. Logan.
It's from like hot water.
Hot water gives heat? Sure, Mari.
Like wind that's hot.
Wind that's hot, like the sun when you're outside and it's hot outside. Jared.
Like when an asteroid comes through, it gets super hot and forms to like a little wall.
Okay, that is one way that could have heat. Are you ready to see our own ways of seeing heat? We are going to try this experiment. So at the top it says, how can texture affect the heat produced by rubbing? Say that. Affect the heat produced by rubbing. So the big question is, that's kind of a fancy thing for saying texture, which is like touch your pants. Are your pants the same texture as your neighbor's? Oh.
No.
Caden, is your shirt the same texture as your neighbor's? No, because textures are different, like thicknesses and surfaces are feeling different. So we're going to try to rub some textures together. Wait, are you ready for this part? We're going to rub some textures together, and we're going to see if heat is produced. Okay, so the first one, touch number 1 on your paper, it says we are going to rub 2 plastic squares together for 10 seconds. Wait a minute. Plastic squares? Where do we get plastic squares? You're right. On your table, I have prepared some plastic squares for you. So there are only, whose turn is it? Thank you. There are only 2 per table per group. So you're going to take turns, and we're going to count to 10 quietly, whisper quiet, and rub them for 10 seconds and see if heat comes from these plastic squares. I'm going to tell you who goes first in just a second. And then after that, we need to record, because part of being good scientist is recording what we are observing and what we are exploring. So part of this, we're going to write down what we feel when we rub these together. But we're not going to do it till everybody in our group tries it, okay? So the person in your group, I'm going to give you your groups because you have only 3 and 4. The person in your group with the longest hair is going to rub these first. And then after we do my turn. After we do the plastic, you're going to do the sandpaper, which is another type of texture. Wait a minute. Sandpaper? That feels way different than the plastic. All right. Person with the longest hair goes first. You're in that group right there. You're right here. Kaden and Elena and Jared and DJ. Yeah. And then you 4 and Isaiah and Slava and Sophia right here and Adonis right here. So Slava, she has the longest hair. She's going first. Give her the clear one. Okay, watch me do it. Ready? I didn't say sandpaper yet. I just said plastic. Thank you. Put the sandpaper down. Watch. Plastic people, are you ready? So rubbing 2 things is not like crazy and breaking and rubbing. It's like put them in your hands, kind of in your palms, and rub like this and see what you can see. And you kind of have to be careful because the ends want to roll. Okay? And you're going to count to 10, the rest of you. Ready? Whisper count with your group. Ready? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. What did you see? What did you feel? Switch to the next person next to you in your group.
Switch to the next one.
Yep, first, hand it to him. Ready, go. And whisper count, go.
Elena did more than 10 seconds.
I think we're okay. Good. What'd you feel? Okay, pass it to the next person. Let's try it. You need to sit up, please. Thanks. Okay. Whose turn is it now?
Kaden.
No, Kaden, you're in this group, babe. Okay, give that to them. You're in this group, Kaden. Give that to her. Ready, go. 10 seconds. 10. Good. What'd you feel? Okay, pass it to the next person. Nope, your next person's in this group. There you go. Ready, go. Not yet. Okay, ready? Last person in your group. Ready? 10 seconds, go. You're in that group, the blue group. Yep. Fabulous. Now put the papers back on the tray, and let's write down, Adonis, what we felt. Did it feel cold like an ice cube?
No.
What did it feel? I wouldn't say hot was the best thing, but warm. So you're going to write, it felt warm. So make sure you write that as you're journaling on your science book. Okay, chop, chop, let's go. Honey bunny, you got 2 pencils under your name tag. Solve your problem right there. In a minute. And then we're going to do sandpaper, but we're going backwards. So the last person to go gets to go first this time. We're going to go backwards in the order we went. And I really would like to say this group did a really nice job of sharing. So make sure you're doing that. It's in your pockets. Okay, pick up your sandpaper. And this one, nope, hold on. Sandpaper is really tricky. I see a couple kids grabbing it. Ready? This is the back of the sandpaper. This is the front. So you put the two fronts together. I know, super silly, huh? And you rub it like this, and you're going to see what you... I know. You're going to see what you see, but I'm going to tell you, you're going to notice the difference if you go like this in your hand for 10 seconds, okay? Okay, last person to go. Who was the last person in your group to go?
Jared.
Sit up on your pockets. Show me you're ready. Ready?
Oh,
Go. 10 seconds. Woo! Thank you for stopping at 10 seconds. All right, pass it to the next person. Ready? Go. Ready? Set, go. And the last person in our group, could you please, ready, set, go. Remove your magnet down. You're not showing me how you do it. And stop. Nice job. Would you put your sandpaper on your tray? And your next question, folks. Are you ready for this? Show me quiet fingers. I see some wiggly folks. Thank you, Adonis. Nice job. Eric, what do you think our next question says? Which material felt warmer? Was it the plastic or the sandpaper?
Plastic.
The plastic? Raise your hand if you think plastic was warmer. Oh, put your hands down. Raise your hand if you think that sandpaper was warmer. Okay, well, I think we're going to go with what the majority is, and the sandpaper was warmer. Okay, so on our paper, the sandpaper felt warmer. Oops, my pen got a little out of control. So on our papers, making sure that we're journaling what we just did as scientists. Thank you, Jared, for doing a nice job. Do you need another pencil? Okay, put that in the broken one then. Calm your body. Nice job today, Logan. Okay, and then my next question is, how can we explain that the sandpaper was warmer? It wants us to explain our thinking. What can we say about that sandpaper feeling warmer? What do you think, Ella? The outside felt warmer to you? What do you think, Adonis, with that sandpaper feeling warmer?
I think it felt way warmer.
Way warmer. Why do you think it felt way warmer?
Because when I felt the sides there, it was getting so warm.
Yes. We're going to do one more thing. Are you ready? Our last question is inferring what we just did, and it says, does rubbing rougher materials together produce more or less heat? So we did that super smooth plastic, and then we did the rough sandpaper, and Adonis and even Ella were saying the sandpaper felt a lot warmer, and it's rougher, right? It's a rougher material. Do you think that produced more or less heat? More. I think you're right. Okay, we're going to do one more thing. Ready? Put your hands together. Yesterday, I stood outside and sold Girl Scout cookies for 2 hours in the cold wind. And you know what I did to get my hands warm? I did this. Ready? You're going to rub your hands. We're going to whisper count. Ready? Go. 10 seconds. Are your hands warmer?
Yeah.
Yeah, and sometimes when we don't need them to be warmer, they probably look redder, and you could probably feel my heat because my hands are warmer now. Nice job. Okay, on your paper, you're going to write, yes, rubbing rougher materials produces more heat at the very bottom. Okay? I lost my pen and my place. Rubbing. Rougher. This one's kind of long. Do your best. Produces more heat. I know that one's kind of long, and do your very best to make it fit on your paper. Nice job, Ryder, getting a start on that. See if I can get this pulled up for our final part. Computer's been kind of finicky. Okay, just a few more seconds and we're going to turn our attention to one last piece of our lesson. Let's see if I can get this to work again. Oh. Okay, I'm just trying. It works that way. It doesn't want to be nice to me, though. Oh, just kidding. Okay, my computer is having a mind of its own. All right, we're just going to finish here, and we will watch our little video next time as an intro to the rest of our unit. So will you repeat to me what your target was? Who remembers what we said our target was in the beginning? Slava. What? Heat. We are working on heat. We talked about heat as a form of energy. Yes. DJ.
Energy.
Energy what?
What energy is?
What energy is? Anyone else care to paraphrase? Ella? You can make energy. You did. You did, and you used it. Yes.
How you can use energy.
Keep working on that. Slava, try it.
How do we use energy?
How we use energy? It actually is I will know how energy is used. You kind of said that in lots of different ways. Okay, we're going to transition to math next.